I am Dr. Subramanian Swaminathan, a senior consultant, previously working at ICMR VCRC here as a scientist F. Now I joined as a senior consultant in ICMR Vector Control Research Center itself. Now I'm going to give a lecture on the leishmaniasis, burden, program targets, epidemiological determinants. So you all aware of the disease leishmaniasis. It is caused by leishmania parasites and transmitted by sandflies. So this is the contents of my presentation is first, it's given here. First, I will give an introduction to leishmaniasis, then disease burden for CL, VL, cutaneous leishmaniasis, visceral leishmaniasis, and PKDL. And third, changes in dialysis between 1990 and 2013. And fourth is visceral leishmaniasis in Indian subcontinent. And then 5, program targets. 6, epidemiological determinants. And I finally model-based analysis of data from the Indian data, which will be used for forecasting VL outbreaks in India. So you all know that leishmaniasis is caused by leishmania parasites, which include leishmania donovani, leishmania infantum, mostly, and there are about more than 20 leishmania parasites are known to infect human across 98 countries or union territories, of which leishmania donovani, leishmania infantum are the most causing most of the infections. The vectors include phlebotomin species as well as Leishmania species, which transmits the infection to human and or animals of animals. So there are 4 forms of visceral leishmaniasis. The first one is visceral leishmaniasis by VL. It's also shortly known as VL or also known as Kalasar, the most serious and life-threatening disease if left untreated. And post-Kalasar dermal leishmaniasis is the second form. It's called as PKDL. And third one is cutaneous leishmaniasis, in short form CL, the most common form of the leishmaniasis disease. And then the final one is mucocutaneous leishmaniasis, shortly as MCL, the most disabling form of the leishmaniasis disease. And the next aspect is I'm going to say something about the disease burden due to CL, VL, and PKDL. So we know that as per the WHO report in 2018, the total number of CL and VL cases by WHO region is shown in this figure from 1998 to 2020. You can see that the Eastern Mediterranean region, in the Eastern Mediterranean regions, most of the CL cases, the left panel shows the cutaneous leishmaniasis cases reported in the world. And you can see it starts increasing from 1998 to until 2019, and there is a small decline afterwards. Mostly in the Eastern Mediterranean regions, these are all the cases, cutaneous leishmaniasis cases are occurring mostly. And then second is the African region of the Americas, and thirdly the African regions. These three regions contributes maximum of the cutaneous leishmaniasis cases. Then if you look at the right panel, that shows the number of VL cases reported over the period from 1998 to 2020. And you can see very clearly the Sierra region contributes highest burden compared to all other regions. And in 1998, it starts increasing, and then it reaches a peak in 2007. And then also in 2012 again, it declines over a period of time in 2020. Most of these cases are occurring in Southeast Asian region compared to all other regions. Secondly, to EMR, Eastern Mediterranean region, and then African region. Okay, so you can see the cutaneous leishmaniasis cases are steadily increasing from 1998 to 2019, and then there is a small decline. Whereas in the VL cases are increasing, and then there is a clear decline of cases from 2012 onwards, and it is going below 10,000 cases in most of the regions. If you look at the PKDL cases by WHO regions during 1998 to 2020, you can see the pattern is similar to that of leishmaniasis VL cases, and it goes up until 2017, and thereafter it declines. The yellow line shows all reporting countries how the trends in PKDL cases are. It started increasing from 2014 to 2017, and then it declines to 2020 around 500 cases. And most of the cases are occurring only in zero regions. So PKDL cases are mostly occurring in zero regions. And you can see in the Southeast Asian Asia regions, the maximum cases occur, whereas no cases are reported in AMR or in EU or European Union region or the West Pacific regions. So if you see the next slide here, the distribution of CL cases by age group and gender between 2014 and 2020 in high burden countries. And you can see the more cases are occurring in the age class more than 15 years of age class, that is in brown color here in the CL cases. And then also you can see females are more, male and females are equally affected by this disease. If you see the right panel, you can see that both male and female are equally affected, the green and blue shades in these bars, whereas the age class affected is highest in the 15 years and above, that is in the brown color in from 2016 to 2020, you can see here. Here we are seeing the distribution of VL cases by age group and gender between 2014 and 20 in high burden countries, where as you have seen in CL, the VL cases are more than 15 years of old, the brown color here in the left panel, whereas and more females than their counterpart females are affected in case of VL compared to CL. There we are seeing that both male and female are equally affected, whereas in VL we are seeing that the more females are affected than that of CL, than that of males. So here also, the people with more than 15 years of old are more affected, but here the females are more affected than that of males. The CL cases, new cases reported in 2020 are displayed here. This is by WHO weekly records from the WHO, and it shows that in 2020 more than 5,000 new CL cases were reported from mostly from Brazil and Pakistan. So Brazil in this the brown area here, this area, and then here the Brazil here. These two areas are mostly affected, and they contribute more than 5,000 cases in 2020 itself. If you look at the visceral leishmaniasis cases, new cases in 2020, and more than 1,000 new VL cases were reported from India and Brazil. The pink here in India and Brazil, you can see that. And most of the countries reporting imported VL cases are Uganda, 68 cases, highest number of cases are reported in Uganda, where the new cases are imported there. And next France, and then Ethiopia and Greece, goes like that. And most of the cases are in India and Brazil. When compared to CL, here the Brazil and Pakistan are contributing more, and in VL, the Brazil and India are contributing most of the cases in 2020. Next, we'll look into the changes in dialysis between 1990 and 2013. So how the disability adjusted life years have changed over the period from 1990 to 2013, we are going to look into that. So the picture shows here in 1990 how the CL cases are, CL dialysis are compared to 2013. So these dialysis are age standardized, and you can see the global mean age standardized dialysis are 0.29 per 1 lakh people in 1990, which has increased to 0.58 in 2013. This is a report based on until 2013 data reported by others in Lancet, published in 2016. So you can see of the 306 diseases assessed by the Global Disease Burden Study in 2013, CL ranked 251 in 1990, and it has come down to 249 in 2013. Of the nine of the countries are significantly high dialysis compared with the mean dialysis. So the 9 countries are Afghanistan, Sudan, Syria, Yemen, Iraq, Burkina Faso, Bolivia, Haiti, and Peru. So these are the 9 countries which are ranking highest in contributing the tallies to the global burden of leishmaniasis, cutaneous leishmaniasis. And if you look at the percentage change in global CL, which is age standardized tally from 1990 and 2013, you can see that regions with the most tallies are Andean Latin American region, and then North Africa and Middle East, West Sub-Saharan Africa, and Southeast Asia. The tallies are highest in Andean region, and then Andean Latin America region is 3.27, and then it's next is North Africa also highest, and then Middle East, Western Sub-Saharan Africa, and South Asia. Based on the 1721 global burden of disease regions, 4 regions with no CL prevalence, they are Australia, Eastern Europe, high-income Asia-Pacific countries, and then high-income North America. These are the 4 regions where no CL cases are reported. Prevalence is nil. And in 19 of the top 50 countries in Sub-Saharan Africa, 13 in North Africa and Middle East, and 11 in Latin America, 5 in Asia, and 2 in the Caribbean region are listed as top 50 countries, top 19 countries where the prevalence is there. Of the 50 countries with the most CL age distributed tallies, 33 had positive median percentage changes in tallies between 19. 33 countries have, out of 50 countries, 33 countries show that there is an increase in the burden compared to the 1990 burden. The greatest increase noticed in Sudan, Iraq, the Gambia, Benin, Venezuela, Paraguay, Ecuador, and Honduras. These are the countries where there has been highest increase in the burden, disease burden, disease burden. And we now look into the VL incidence, VL in Indian subcontinent. I am restricting to the Indian subcontinent now, where we are looking at only the visceral leishmaniasis. No cutaneous leishmaniasis prevalent in Indian subcontinent. So we all know that visceral leishmaniasis, also known as Kala-Azar, is caused by Leishmania donovani parasites transmitted by the fly Phlebotomus argentipus. Humans are considered to be the only reservoir of this infection. Chronic disease with chronic fever, enlarged spleen, and anemia or pancytopenia are the chronic versions. Then, if untreated, this will become deadly. The disease will become deadly. The population affected are poorest of the poor living in rural areas. Equally affected children and adults, men and women. Most affected countries in the Indian subcontinent are India, Bangladesh, and Nepal. Outside Indian subcontinent, Brazil, Ethiopia, Kenya, Somalia, South Sudan, and Sudan are the mostly affected countries. So this picture shows the leishmania burden in 0 regions, Southeast Asian regions. You can see that of all the entities, leishmaniasis contribute the maximum, which occurs in Asia South. Second, of all the entities, leishmaniasis is the first one, and then it contributes, Asia South contributes maximum leishmania burden in Southeast Asian region. All other diseases are next. The next one is lymphatic filariasis. So it goes on like that, but leishmaniasis is highest disease burden of all the neglected tropical diseases in Southeast Asian region. This picture shows the real leishmaniasis disease burden in the Indian subcontinent. Here you can see the number of cases in thousands, and the distribution starts from 1977 to 2016. It is given here. The number of Kala-Azar cases reported by Nepal, Bangladesh, and India are shown here. See, the Nepal is shown in yellow color, Bangladesh in blue color, India in red. You can see most of the cases are occurring in India compared to Bangladesh and Nepal. Next to Bangladesh is Nepal. So you can see the cases are cyclic in nature. In every 12 years, it goes a peak and then declines. It goes on like that. And of course, we are seeing a reduction in incidence from 2011, 2009 onwards. 2008 onwards, there is a significant reduction in cases, the reported cases in India. You can also see that the number of cases also declining in both Bangladesh and Nepal, much lower than that of India. This is being reported in British Medical Journal. This is taken from BMJ. And in India, if you look into that, the Kala-Azar endemic states are 4 states. They are the Bihar, Jharkhand, West Bengal, and Uttar UP. In Bihar, almost all the 33 districts in 458 blocks, the disease is prevalent. The population affected is about 62.3 million cases, 3 million. And in Jharkhand, 4 districts are affected out of 30, in which 33 blocks are affected by this disease. And the population affected is about 5.3 million population. And in West Bengal, 11 districts are affected. Overall, 120 blocks are covered by these 11 districts. And then population is endemic is 50 million population here. And in UP, only 6 districts are affected on over 22 blocks. The population endemic in this region are 11 million population. So these are the 4 districts, 4 states in which about 633 blocks are affected, and we are very significantly contributing for the VL cases in the global burden. This picture shows the trends in number of Kala-Azar cases with the milestones in the Indian National Kala Elimination Program from 1977 to 2020. You can see that the number of VL cases are in the bar chart shows the number of VL cases reported over the period from 1977 to 2020. The cases are as you were saying earlier. It's in cyclic pattern. Every 12 years there is a peak, and then it declines after 2008. And in India, it comes down to around 500 or 6,600 cases in 2020. And the different phases of these interventions are listed in the boxes, in the blue boxes. The period from 1977 to 1988 or 1990 until 1989, the DDT for Kala-Azar was used under the malaria control program. And from 1990 to 1991, centrally sponsored Kala-Azar control program was in operation. And in 2010 to 2010, the national public health policy was initiated, and the elimination program in India was initiated. And then in 2000, introduction of as per the Zero Memorandum of Understanding, tripartite understanding between India, Nepal, and Bangladesh, they introduced the multi-phosine and RDT's integration with the National Health Mission 2005. So this was introduced. And then in 2009 to 2013, the World Bank supported the Kala-Azar elimination program. And in 2015, hand compression pump was used for indoor residual spray. And introduction of single dose lamp was introduced in 2014. Declaration of elimination was done in the countries have declared elimination by achieving elimination by 2017. And the introduction of synthetic pyrethrum was done in 2016. And an independent assessment was done in 2019, which showed that there is a clear declining of incidents in India. Whereas in Bangladesh and Nepal, already the cases have come down below 1 per 10,000 population. Here, this picture shows the number of implementation units above or below the target threshold. There is 1 per 10,000 population in Indian subcontinent. The blue bar shows the number of IUs which are below the elimination threshold, that is less than 1 per 10,000 population. And the brown one shows the IUs in which elimination, they are above the elimination threshold of 1 per 10,000 population. You can see that in the zero region, about 738 IUs are below 1 per 10,000 population, whereas 18 IUs are found to be more than 1 per 10,000 population. In India, out of 633 blocks, we have 617 blocks with less than 1 per 10,000 population, and in 16 blocks, we have more than 1 per 10,000 population. That means in 617 blocks, our country has eliminated the disease, reached the elimination goal of less than 1 per 10,000 population. Whereas in 16 blocks or 16 IUs, it is more than 1 per 10,000 population. And in Bangladesh, almost it is 100, all the 100 IUs are below the elimination threshold of 1 per 10,000 population. And in Nepal, only 2 out of 23 IUs are above 1 per 10,000 population. So both Bangladesh and Nepal are almost reached the stage of elimination, whereas in our country, we have the highest burden country, which has still 18 IUs, which are more than 1 per 10,000 population, which is the elimination threshold for stopping the for achieving the elimination goal. Next, I'm going to give a review of the program targets. Here we are just looking at the different definitions first, and then we are listing out the different indicators for this purpose. BL elimination target at IU level. The target at the elimination IU level is annual Kala-Azar incidents below 1 per 10,000 population in all the IUs, that is sub-districts in India and Upasila health centers in Nepal by 2030. That is the elimination goal. But recently, a meeting of the Regional Technical Advisory Group meeting on visual leishmaniasis and the national BL managers of endemic member states in 2020, they set 0 cases, and they provisionally accepted that setting 0 cases and 0 transmission as aspirations goals by the 2027 and 2030 respectively, provided additional tools to measure and achieve 0 transmission are developed. So you can see that 0 cases is the goal by 2027, and then 0 transmission is the goal for 2030. So what is Kala-Azar case definition then? A case of Kala-Azar is defined as a person from an endemic area with a fever of more than 2 weeks duration with splenomegaly who is confirmed by an RDT or biopsy. This is the definition of Kala-Azar simply. And the Kala-Azar treatment outcomes are 4. One is cure. A patient is considered clinically cured if he or she has completed full treatment and there are no signs and symptoms of Kala-Azar. Secondly, non-response. Signs and symptoms persist or occur despite satisfactory treatment for more than 2 weeks. And relapse means any reappearance of Kala-Azar signs and symptoms within a period of 6 months after the end of treatment. Treatment failure means either it may be non-response or relapse. In both the cases, it is called as treatment failure. PKDL case definitions. So there are 2 definitions. Probable PKDL, that means a patient from a Kala-Azar endemic area with multiple hypopigmented macules, papules, plaques, or nodules who is RDT positive. For confirmed PKDL, the probable PKDL, all the things will be there, but you will also have who is a parasite positive in slit skin smear or biopsy. In this case, a case is considered as confirmed PKDL. So that's additional things in relation to probable PKDL. Then treatment outcomes in case of PKDL: initial cure, clinical improvement at the end of treatment, defined as a considerable reduction in the number and size of skin lesions. That is initial cure. Final cure is clinical cure 12 months after the end of treatment, defined as a complete resolution of macules, papules, plaques, and nodules. So these are the definition of PKDL outcomes, treatment outcomes. There may be initial cure or there may be final cure. Initial cure are in terms of the reduction in the number and size of skin lesions, and final cure is clinical cure 12 months after the end of treatment, and it's defined as complete resolution of macules, papules, plaques, and nodules. So monitoring clinical outcomes, not a key indicator, but what are the indicators we use for this purpose? For final cure rate is number of patients. Hello? I'm not able to hear. Hello? Final cure rate is equal to number of patients with the final cure divided by total number of. Madam, I'm not. It's not audible to me. I'm not able to hear. Hello? You want to say something? Hello? 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 Can you hear me? Hello? Hello? Hello?
Yes, audible, sir.
No one is responding. Someone is asking some questions. I am not able to hear them clearly. So, okay, shall I go ahead?
Yes, sir. Go ahead, sir, please.
Right. So the monitoring clinical outcomes includes, these are all not a key indicator, but the outcomes only I am giving the definition of different indicators. The final cure rate is equal to number of patients with the final cure divided by total number of persons treated, started treatment. And treatment failure rate is total number of non-responses plus lapses plus cause related deaths divided by total number of persons started treatment. Loss to follow-up rate equal to number of defaulters plus number of losses to follow-up divided by total who started treatment. Mortality rate equal to number of deaths divided by total number who started treatment, and initial cure rate equal to number of patients the initial cure divided by total number who started treatment. This is recommended for at district level as an indicator for monitoring the outcome. Program targets at implementation unit level. So these are the different targets that is being used by the program, which are detection rate, which is defined as number of new cases detected per year in the district or UHC or sub-district divided by total population in the same area. That is the detection rate. And treatment completion rate is number of patients that took a full course of first-line drugs divided by all new call-answer cases that started treatment in a given period. Coverage rate of IRS for the vector control, it is called number of households protected divided by all houses at risk. Treatment target for treatment completion rate should be greater than 90%. That is the target for program target at different IU levels in the programs. They follow these three indicators: detection rate, treatment completion rate, and coverage rate for IRS vector control. Next, I'm moving on to the epidemiological determinants, which includes, I have taken these results from the study which has been conducted, a systematic review of different studies and meta-analysis. See, you can see that the number of studies by different countries here. Brazil, Iran, Ethiopia contributes the maximum number of studies compared to India and Nepal. So you can see CL cases, most of the CL studies are from Brazil, Iran, and Ethiopia, and most of the VL studies are from India, Nepal, and Brazil also. So these studies suggest that the determinants can be, most of the determinants can be, out of 102 studies conducted, there are 68 studies which says that social and demographic factors are significantly contributing for the number of cases, and then the landscape secondly, and then the climate parameters are contributing for the epidemiological patterns in different countries. And then the first one shows the BL, the second one shows the CL. Out of 82 studies in CL, 52 studies contributes about, says that social and demographic factors are significantly contributing for the epidemiological patterns in different places, different environmental regions, and then socio and demographic factors, and finally the climate factors. In both CL and VL, the major determinants are social and demographic factors, and then secondly the demographic landscape factors, and then the climate factors. What are these factors we are going to see here? The next slide. So the socio-demographic factors include socioeconomic status, water supply, sewage system, garbage collection, and then characteristics of population, age, gender, education level, migrant. And this influences the quality of life. Houses built with straw and mud provide shelter to sandflies. They are contributing for sandflies breeding, and therefore sandfly population also higher in these socioeconomic conditions. So when we see the socioeconomic conditions, and all these factors are mostly contributing for the sandfly proliferation, and thereby there is an increase in sandfly population, and hence the cases occurrence also more in these regions. And then if you look at the landscape and environmental variables, they include population density, they include vegetation, presence of water bodies, altitude, slopes, and soil type, urban and rural landscape, and construction activities. This also contribute maximum for the sandfly population dynamics, and therefore this contributes secondly for the both CL and VL cases. More cases are occurring in these regions. And climate parameters are mostly temperature and precipitation. Condition may be favorable to sandfly development. That's why the climate parameters are more important. Lastly, these are the three categories of factors. which contributes for the epidemiology of the leishmaniasis in the different countries. And finally, I'm going to talk about forecasting VL outbreaks in India, and through which we are also deciding how the environmental parameters are risk factors of VL transmission in India. This is a collaborative study between VCRC and the London School of Hygiene and Tropical Medicine, which are coming under the umbrella of Speak India program. So I'm going to speak about this one a little more. So here the aim is to predict the VL incidence at block level. For this purpose, we use the data from routinely collected VL case data from CAMIS, Kalasar Management Information System, for short-term prediction of block level incidence. And secondly, we use VL case and environmental covariates data for predicting block level risk of resurgence. So we use a spatial statistical model, and we identify the determinants of risk of resurgence, and finally predict the block level risk of resurgence using an integrated nested level approximation. I'm not going to say much about these technical aspects, just the data and then the results I'll be showing. Here we are seeing that we are using the data from 502 endemic blocks in Bihar and Jharkhand, which includes 469 from Bihar and 33 from Jharkhand. And we use monthly block level diagnosed cases as reported in the CAMIS database from January 2013 to May 2021. We use the data for model training from 2013 to 2018, and for model testing and forecasting from 2020 to 2022. 2019 to 2022. And then we have the monthly block level environment and climate covariates for five climate variables. Here it includes enhanced vegetation index, soil moisture, minimum temperature, maximum temperature, land surface temperature, and bioclimatic variables, which are Bio 1 mean temperature, Bio 3 isothermality, Bio 12 precipitation, and also finally the demographic variable list for each of the block for different months and years. So that is population density per square kilometer. You can see this in this picture, a clear declining trend in the VL cases from 2013 to 2019. Starting from 2013, it declines clearly, and with a different peak in different periods. The VL cases are declining, but when you see the right hand side, you can see that although there is a clear declining trend in the region, but we are looking at the cases are more than 6 in some of the blocks, and it is very highly heterogeneous from block to block and from time to time also. For this region, so for modeling this distribution, we use the negative binomial regression type of model, which incorporates the effects of environment, climate, and demographic covariates, space, time, and space-time interactions. So cases at a block in a month are modeled as a combination of covariates, space plus time, and space-time interactions. We have fitted about 45 models, including 4 types of space-time interaction models, and the 4 types of interaction model also includes a type 4 space-time interaction model, which is being selected as the best model based on the deviance information criterion, which measures the fitness of the model to the data. So this is the space-time interaction model description here. We have considered the type 4 interaction, which is area-specific temporal trends spatially correlated, or spatial patterns are temporally correlated. That's the meaning of type 4 interaction here. We use the right-hand side, the right-hand side, type 4 interaction here. This interaction says about the area-specific temporal trends in incidents are spatially correlated, or spatial patterns are temporally correlated. Both are directly related with each other. And then we are going with, after fitting the model for a fixed effects model, that is only with the covariates, we found that 5 variables, they are Bio 3, Bio 12, minimum temperature, population density, and enhanced vegetation index. These are the 5 variables which are directly positively correlated with VL incidence in India. And then 2 variables we found that maximum temperature and soil moisture are negatively correlated with the VL incidence in India. And then this figure shows the fitted, observed, and predicted annual incidence per 10,000 population using the data from 2013 to 18. You can see that 2013, the observed data are shown in the maps, the top panel, whereas the predicted one are given in the bottom panel. And we can see 2013, the predicted cases are in close agreement with the observations. And I'm not showing remaining areas because of space and time here. So we are looking at the predicted predictions or forecast in 2020 and 2021. In 2020, and we can see the observations are closely mimicked. The predictions are mostly closely reflected the observations. And in 2021, we have the data up to only May 2021. So whatever we are seeing is here the cases are not exactly matching with the 221 observed one. The predicted cases are not exactly matching with observed one. But we are having that there are some spaces where the cases are seems to be more than 0.5 per 10,000 population in some of the blocks here. Whereas in this is Bihar and Jharkhand are shown here. The round one are Jharkhand, where you are seeing that the cases are again higher in predicted compared to the observations. This may be due to because we have only cases up to May 2021, and whereas the model predictions are shown for up to 1 year. And then in 2022, we are expecting a higher increase in burden. That is, it will go up to 1 to 10 cases per 10,000 population in Jharkhand, whereas in Bihar, in some of the blocks, it happens. It's expected to be occurring. And the three blocks are Kathikondi in Tumka district, Amarapara and Hirapur in Pakur district are above the elevation threshold of 1 per 10,000 population here. So next we are seeing here, the next picture shows, here we are seeing the three blocks in which the annual incidence is more than 110,000 population, and how in 2022. So what happens to them in these are in Jharkhand actually more than 1 per 10,000 population in 2022. That alone we are looking at the trends, how the trends in these blocks. We can see that there is a clear declining in the point prevalence, point incidence, but the upper 95% confidence shows that there is an increase in the expected to increase. It may go up to 30 cases per 10,000 population. So there is a danger beyond 2021. We are expecting an increase in the number of cases which may go up to this level. So the point prevalence, point incidence alone not sufficient. We should also consider the upper confidence interval of the predictions. Then in Amarapara district, which shows that again the same pattern, and in Hirapur it shows a different pattern. These pictures clearly shows that though there is a declining trend in the point prevalence, and we are expecting an increase in cases. Say for example in Kathikund it is more than 1, and in Amarapara also it is more than 1, and Hirapur also it is more than 1 per 10,000 population. The 90% confidence interval clearly shows that there is a danger that it may go beyond 1 per 10,000 population, even up to 40 cases per 10,000 population in some of the blocks. So then we look into the spatial temporal variation in 3 blocks with the annual incidence 6 per 10,000 population in 2013 in Bihar. This graph clearly shows that a clear declining trend in the cases incidence from 2013 to 2022 also. But if you see the confidence interval, it shows that it may be higher than that of 1. So the similar patterns are shown in Parasoni as well as Basanpur district. Basanpur district shows high variability in cases. These pictures clearly shows that the model predictions clearly differentiates the block level variations, and this is being also seen in the predictions also. And here we are saying the spatial temporal variation in 3 blocks. We have taken some examples of the districts only, blocks only. So annual incidence 12 per 10,000, more than 12 per 10,000 population in 2013 in Jharkhand, and we can see that the trends are still worse than that of Bihar. So the initial cases are 15 per 10,000 population declines, and it is above 1 per 10,000 population, even the point instance, whereas the confidence interval clearly shows that much higher levels of incidents may occur in 2022, and it is again indicating that the whatever we achieved may not be truly reflecting the situation. It may be higher than that of what we have observed now, and it's giving us great danger signal to the program as such. And here we are seeing the spatial temporal variation in 4 blocks with the annual incidence of 0.01 per 10,000. That is less than 1 per 10,000 population in 2013. How the trends in these blocks, we are saying that Barani, Kobalpur in Bihar, and then Sahibganj and Udva in Jharkhand. These 4 blocks we have taken as an example how the model predictions are. You can see a clear prediction of the trends, the observed trends as well as the predicted trends are hand in hand in Bihar as well as in Kobalpur, and they are within 1 per 10,000 population, even the upper 95% confidence interval also. And in Sahib Ganj, this is again more or less close to the observations, and we are expecting less than 1 only in 2022. Whereas in Udva, it seems to be there is a clear higher variations in the number of cases, incidents per 10,000 population, and we are saying that in anticipating the cases may go up even more than 1, up to 5 cases per 10,000 population in areas like Udva, where the annual incidence was less than 1 per 10,000 population in 2013. So in summary, and what we have done so far, yes, a spatial temporal model with the environment and demographic covariates could explain spatial temporal patterns in real incidents. And the short-term predictions accurate for more than 90% blocks with incidence less than 1 per 10,000 population. Potential for forecasting outbreaks and trend incidents. And our findings are potential for supporting targeting of resources as endemicity drops down from 2013 to 2020 now. Thank you.